So you guys have already done this part. So when we are deciding between ionic or covalent, what is the big question that we're always asking? Does it have a metal, right? So we know where the metals are on the left-hand side of the periodic table. The right-hand side is all non-metals. So you should have been looking through to figure out if it had a metal. What I want you guys to listen to carefully is as I am saying these, I'm not going to just say the formulas. I'm going to say the actual name. And I want you to kind of figure out which one am I adding prefixes to. So prefixes means like mono, di, tri, penta, tetra, all those, okay? So if you hear me put that, just kind of maybe make a dot on your paper, and that way you kind of start making that connection to which ones are going to use those prefixes and which ones are not, okay? Just kind of listen as we're doing that. And then we'll go over this bottom one together. Okay, so for the first one, we had magnesium oxide, ionic or covalent? Ionic, good. Then we had ammonium chloride. All right, so you should have said covalent. Please put a star next to that, though, because it is actually ionic. If you notice, actually, we'll come back to that. All right, just leave a star next to it. It's something that contains a polyatomic ion, all right? So we'll talk about that hopefully today. If not, it'll be tomorrow. All right, then we had hydrogen monochloride, covalent. The other way we name it is hydrochloric acid, okay, but we're not worrying about acids right now. Potassium iodide, ionic, good. Sodium hydroxide, ionic. Nitrogen dioxide, good. Aluminum phosphate, ionic. Iron 3 chloride, ionic. Diphosphorus pentoxide, covalent. Dinitrogen trioxide. All right, so which ones did I use the prefixes for? Like in terms of covalent or ionic, which one did I do it more to? The covalent ones, yeah, and that's exactly what it is. You don't have to turn your page. This is just on your little, on the back of the first page, just so you know, you have the little flow chart. We'll come back to it today. But basically what we see here is that we had to figure out ionic or covalent. So we ask ourselves, does it have a metal? So for the ones that had a metal, we have this type of naming. For the ones that are covalent, we see that we use prefixes. If you notice, that is the only ones that we use prefixes for. Okay, so I wanted you guys to start hearing some of those names, because that's going to be what we kind of cover a little today, is how to name them. Okay, so we'll come back to that in a little bit. And prefixes down are at the bottom of the page, by the way. So you have those. We'll need to know Roman numerals, all that good stuff. So, all right, down here, the second part of your warm-up was show the electron transfer and formula for the ionic bond between magnesium and sulfur. So hopefully you still had your challenge question off to the left. So a lot of you guys had a chance to try out this challenge question where you had to put together calcium and nitrogen or aluminum and bromine, right? If you didn't do those two, you really definitely want to have this one on your paper somewhere so that you can see that when you go to forget about the arrows. Because today, I might decide that you guys deserve to learn the shortcuts. We'll see how the rest of this warm-up goes. All right, so back to here. We got to show the electron transfer. So that means using the arrow thing. So when we show the electron transfer, what is the first thing that you had to figure out? Yeah, the dots. So we had to write the electron dot notation, right? So magnesium is in group 2. So how many valence electrons does he have? 2. So we're going to draw 1, 2 dots. Sulfur is in group 16. So how many dots does he get? 6. Good. So we're going to go 1, 2, 3, 4, 5, 6. Next step is we show the actual transfer. So we're going to take that first one. We're going to give that one over to sulfur. Sulfur still doesn't have 8. This one still doesn't have 8. Okay, when I say that it doesn't have 8, you want it to not have any, right? The cations need to give away all their electrons. The anions need to take all of them, right? So for here, this one still has a 1. This one still has a 1. So we put them together. So we're going to go ahead and draw that arrow to the other missing gap right there. Okay? And now we're good. Everybody's satisfied? All his electrons got donated. His got filled up. We're good. So we're going to go ahead and write in brackets what's left over. So magnesium, will he have any dots around him? No. So it's showing that he kind of moved back in energy level. He's now isoelectronic to neon. That just means the same electron configuration as neon. All right, but what are we going to put on the outside of this bracket? +2, because he got rid of 2 electrons, 2 negative things. So he ended up with a +2 charge. Sulfur, are we going to put any dots around him?
Yes.
8. Good. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. We're going to put brackets around him. He gained 2 electrons. -2. Now we count up what we've got. How many magnesiums do we have?
1.
Okay. How many sulfurs do we have?
1.
Good. And that's our final formula. Magnesium sulfide. Okay?
So there's no number, that means 1, right?
Yep. When there's no number, it means 1. Good. All right. Are there any questions from the warm-up? Then I need everyone to turn to the back of page 2. The back of page 2. So it says writing formulas for ionic compounds with the crisscross method. Okay? So I will go ahead and say that we can move on to the shortcut. All right. So really quick, flip your page up, and I want you to write something on your little flow chart. Okay, so when we were on this little flow chart, sorry, I totally forgot that I was coming back to that. All right, on the flow chart, the type of bond, we were asking ourselves, does it have a metal? If we knew that it has a metal, then we go ionic. If it does not, we were going covalent, and we got to hear it a little bit today that Miss Vogel was using prefixes to name some of her covalent compounds, or her molecular compounds, right? So when we're ionic, the next question that you come to is, how many elements does it contain? How many elements does it contain? So what do you notice on the periodic table? What does every single element start with? A capital letter. Yep, a capital letter. So if you look at any periodic table, they all start with capital letters. So when you're trying to figure out how many elements something has, you're trying to see how many capital letters there are, right? So when you're talking about how many elements, it's not talking about little subscripts and counting up the atoms. It's talking about how many different types of elements are there. Okay, so how many? At least 2 capital letters. Okay? All right. So we're going to stress the binary today. So we're going to go this way. So if we had more than 2, we're going to learn about polyatomics next. But 2 for binary is going to be talking about something that has only 2 elements, right? And then we're going to be looking to see if it has a transition metal. Where are transition metals on our periodic table? The D sublevel, right? The little middle section that kind of got cut off in your little charge thing right here. Does everybody see your charges down here, by the way? Okay, did those charges just come out of nowhere? What did we see with that transfer, like notes? Where do those charges come from? Like +2, where did that come from today?
The electrons you're giving off?
Yeah, it meant you gave 2 away. You got rid of 2 electrons, so I'm left with a +2 charge. The -2 that we saw today came from I gained 2 electrons, so I got a -2 charge. So these charges you are going to want today. So something that we took a second to do in first period was you either pull this page out to where you'll be able to see those charges, or you grab one of your little periodic tables or your big blue one, whatever. You need a periodic table every day. But in first period, a lot of people just went ahead and took one of their smaller periodic tables and they wrote down their charges. So I wrote mine at the bottom just because that's where I had space on mine. So I put +1, +2, +3, -3, -2, -1. Okay? So I would recommend you just somewhere on your desk today, it will help you out to have your charges readily available. That's part of the shortcut. You got to know the charges. It's not going to be something you figure out anymore. Okay? Or like I said, on the blue periodic table, if you want to write it across the top, as long as it's your own, you can do that. So we leave transition metals alone. Those guys are known as, or they have multivalent cations, meaning that they can have different charges. And we're going to save that for another day. But you have to figure out what their charge is, okay? Or we give it to you, okay? So we'll talk about that later.
So group 14.
Group 14 would be a plus or minus 4. So I didn't want to write it because I had a big Sharpie. And I didn't want to take up a hole and make it look like a blob. But this is technically plus or minus 4. You just will never have to apply that until we get to covalent bonding. Okay. All right. You guys ready? It's going to be great. It's going to be great. So, with your crisscross method, we are basically going to be taking those charges and cross and dropping them. Cross and drop, okay? I'm going to turn back to the notes if you need to come back up and see my... So, writing the formulas for ionic compounds, crisscross method. So, this is only for binary, okay? Oh, that's what we were supposed to write on your little flow chart, you guys. I'm sorry, I totally forgot. But these are only for binary ionic, okay? Meaning if you have more than 2 elements, you can't use this method, okay? But you still will be doing a version of it. So it's still the same thing. You'll see it later. All right, so first thing that you start with is you're going to write the charges. So instead of drawing out the electron dot notation, you're just going to write the little charge above each one, okay? Then you're going to always write your positive ion first. So positive ions or cations, is that your metal or your nonmetal? Ooh. All right, who is the electrons always going from and to? They were always going from the who? Metals, right? They're the ones who have the extra electrons. Yeah. Yeah. So they can always go from the metals and transfer to the nonmetals. So metals always come first in the formula. Okay? Negative ion, and I'm recording it, so I'll post it, okay? The negative ion comes second. That is your anion or your nonmetal. Okay? You're going to crisscross to find subscripts. So no negative subscripts, meaning the only thing that comes down and across is the number. Do we got that? Don't bring down the charges. Okay. So always reduce to the simplest ratio. So for example, in today's warm-up, you guys had something that was, what, magnesium sulfide, right? MgS? Yeah. All right, so with Mg and S, you don't have to write this, by the way, okay? What would be the charge for magnesium? A +2. What would be the charge for sulfur? -2. Wait, right? Because that's what we saw at the end. When we put them in the brackets, that's where the charges were. Now, as we crisscross, if we're following the rules the way they are, it would be Mg2S2. Is that what we had in our warm-up? No, because they fit together like a perfect puzzle piece, a 1-to-1 ratio. That's why you have to reduce to your simplest ratio every time. Does that make sense? It comes from those drawings. Don't forget the drawings. All right. So let's go down here. Let's start looking at a couple of these examples. So sodium. Sodium is in group 1. So group 1 gets a what charge? A +1. So we're going to put a +1 right here next to sodium. Sulfur is in group 16. So he has a what? A -2. So we're going to write a little -2 right there. Those charges are going to cross and drop. So we're going to draw an arrow from that -2 down to the corner of sodium. We're going to draw an arrow from the 1 down to the corner for sulfur. And now we're going to write out our formula. We're going to end up with Na2S. A little bit easier. Definitely takes up less space, right? So this is the short crisscross. All right, let's do the next one. Aluminum. So aluminum. Why is the +2 at the bottom?
Wasn't it a -2 for sulfur? Well, how is it like Na +2?
No, that's a +1.
No. In the formula.
Na2S1.
The charge for sulfur is a negative. She's asking why is it turned to a +2?
It doesn't. We're just bringing the numbers down.
Oh.
So if you remember, how did we get those subscripts in the first place, you guys? You counted them up, right? How did they fit together? So for this example, this would be the same thing. Again, you don't have to write this, you guys. I'm just showing. So sodium had +1. So we had a 1. I'm sorry, not +1. But it had 1 valence electron. Sulfur had 6, right? So in this instance, you would have said, okay, sulfur or sodium gave away its electron, but but sulfur still needed one more, so we would have drawn another sodium. That would have fit right there. Now, how many sodiums do I have? 2. How many sulfurs do I have? 1. Does that make sense? All right, so remember, that's where the subscripts come from, you guys. It's how they fit together like a puzzle piece. How many do you need of one? How many do you need of the other? It's all ratios. Because ultimately, that over there is a crystal lattice. That is what we're looking at. With that whole sodium sulfide, all that we're saying is that this is showing 1 to 1. So it goes like green, gray, green, gray, green, gray, green, gray. That is a 1 to 1. This would be showing something where I would have 2 of one color and then it would go 1, right? So ultimately, the crystal lattice thing is the whole idea that we're looking at, okay? We just got to know how many go together to make that ratio. Got it? Kind of complicated a little. We're good though, right? Yeah? Let's do another example. All right, so aluminum. Aluminum has a what charge? +3. What does bromine have? Group 17. -1. So we're going to take those. We're going to cross and drop. So we're going to end up with aluminum. Do we write anything next to it? No. And bromine with a little 3. So 3 bromines for every 1 aluminum. I'm sorry. I realize I should probably be writing with my markers so that you guys can actually see through the yuckies. All right, the next one, calcium and oxygen. So calcium is in group 2. What is the charge? +2. All right, oxygen is in group 16. What is the charge? -2. So we're going to say +2, -2, cross and drop. So we end up with Ca2O2. Do we leave it? Absolutely not, because once again, you're trying to see this, right? A 2 to 2 ratio is the same as a 1 to 1. So we're going to write CaO. You reduce it down. Okay, make sense? Perfect. All right, this last one. All right, whew, here's our weirdo. So you see that we put a little 4+. Where is chromium on our periodic table? He is a transition metal. Yep. So transition metals get a little weird. I'm going to go ahead and let you guys do this one still because I don't think it's terribly difficult. But I just wanted to kind of show you on your flow chart what you would be doing if you noticed it was transition. So does it contain a transition metal? Yes. We would have to use the Roman numeral to show the charge of our metal. So when we go to name these, that's going to be the importance of that. Okay? But we have to right now give you guys the charges. By Wednesday, we're going to have to solve to figure out the charges. Yay, fun stuff. Woo. All right. So this one right here would be chromium 4 oxide, just so you know for the name. So we already have a 4+ here. What is oxygen? He's group 16. A -2. We're going to crisscross those. We end up with Cr2O4. Can that stay that way? No. It's a 2 to 4 ratio, so now it turns into a 1 to 2. And that's the final answer. Are there any questions? All right, what I'd like you to do is in the practice part, I'd like you to do all the evens, right? So there's 2, 4, 6, 8 right there, and then 10, 12, 14, 16, okay? I'll show the answers in a couple minutes. Sweet. All right, so what I'm going to point your attention to real quick, down at the very, very bottom of this page, okay, it says naming your ionic compounds. So naming your ionic compounds consists of writing the name of the first element, or polyatomic ion. Again, don't worry about that because we haven't learned about that yet. But you're going to name your first element, write the second element, and change the ending to "ide." Now this is on your little flow chart. So if you ever don't know, you're just saying names of the elements only, and you're ending in "ide." Okay? So that's what it says in your notes. What I'd like us to do is just do a couple of these. I messed up, and I thought that I had put an example or a page of practice for doing the crisscross thing. So I owe you guys that, just so you know. So if you don't mind, go to page the back of 4. The back of page 4, okay? So to the back of the page that we were doing our warm-up on. This is naming binary compounds, okay? Now, for this binary compounds, I don't want you messing with transition metals today, okay? So if you see a transition metal, just circle it, all right? Okay? Don't worry about trying to figure out the name. And don't go looking it up, and don't try to write anything on the line yet. Okay, leave it blank so that we got that. There are 10 that have transition metals. Okay, there are 10 that have transition metals. The other ones you should be able to name pretty okay. Okay, so again, this isn't the crisscrossing. It's just finding the binary compounds, and we're going to be naming them. So, for example, we'll do number 1 together. Okay, we have BaCl2. So, you look to see, is there a metal? Yes. Is it binary? Yes, there's only 2 elements, right? Does it contain a transition metal? No. So we're going to name it as is. So who is Ba? Barium. So we're going to go ahead and write barium. And then Cl is chlorine. So we're going to go ahead and start writing chlorine. This comes with experience. You change it to ide. You chop off any enes and change them to ide. There's so many of these that you're going to write wrong. I'm not going to count off for writing them wrong as long as you're trying it. Okay, as long as you write the ide somewhere, I know that you're attempting it. It'll probably take you all year to finally learn all the exceptions. Because like phosphorus, a lot of people like to say phosphoride. It's phosphide, which is weird, right? Because you're like, okay, how do I know that I have to chop it all off? It just comes with experience, okay? All right, next one. We have NaF. Is there a metal? Yes. Is it binary? Yes. Does it contain transition metal? No, so we're just going to name it as is. So Na is who? Sodium. And fluoride. Good. Okay. Number 3. Ag2O. So Ag is a transition metal, so we're just going to circle number 3. We'll come back to that one. Copper, transition metal. So 4, you're not going to mess with. We're going to mess with number 5? No. Nope. Number 6? Number 7? All right. So now we're down at number 8. So now we have MgS. It's ionic, it's binary, no transition metal. So we're going to go ahead and name it as is. So we have magnesium. And then how do we write the S part, do you think? Sulfide. Good. Lots of people like to say sulfuride. I'm going to strongly encourage you not to do it that way. Okay? But that's all that you're doing here. Okay? So if you'd like, you can take a couple minutes to try to knock out the other ones. Like I said, there are 10 transition metals. So we already found 5 of them. There's 5 more that you're not going to have to do. The rest of them you're going to want to get done. Okay? In 2 minutes, we are going to jump on Schoology for a quick quiz. It should not take you very long. It should not take you more than the 10 minutes. But if you know that your computer needs to get loaded, please start pulling out your computer now. Okay?